Okay, let's continue up the space and rocket review. Oh, that's great. OBS just added a way so I can enable monitoring. Oh, that's pretty neat. Wait. Echo. Ah, nice. Nice. No, 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 no. No. You're not being the ball chat. Okay, that's enough of that. I'm good with that. How's everybody doing? How is Primo? Oh, yeah. False alarm. Everything's okay. I ended Space News after like 30 minutes last night because Bree wasn't feeling too well. And you know what, dude? All things considered, she was like 3 weeks out of the hospital. She was in the ICU 3 weeks ago. So I was like, you know what? I ain't taking a chance. So I drove her to the emergency room. Bree is just fine. When you come off of surgery like that, like what she had, you're on painkillers and stuff, and then when you stop taking the painkillers, right, your body like reacts to it, and it gives you stomach pain. It's because you have to poop. Pretty sure Bree does not want me telling you guys that, but that's basically what's going on. But yeah, I ain't taking the chance, and that's, guys, like that right there is the reason why I haven't been like locking in and doing like 10-hour streams. You don't want to take the chance. I don't want to. I ain't taking the chance. The hell with that, dude. Yeah, exactly. I hate it that simultaneously I don't like it that I'm not here, but I know that you guys understand, but the thing is that ain't how my brain works, right? That's not how my brain works. I believe in doing work. And even though I know, like, I know it's good, I know most of you guys are cool with it, it's still back there going, hey, hey, why aren't you working? You're good enough to work. Come on, go. It's like, so yeah, I'm like, been a little bit of a mess lately, but it's okay. Yeah, exactly, Ernog. That's like why I'm just like, yeah, all right, pal. All right. I'm not taking that chance again. Not taking that chance again, bro. I know you feel family's more important. Yeah, exactly. All right, so we will continue Space News basically with the stories that I wanted to run yesterday, and then there is another thing, some news from today, that's interesting. We'll start with that, and yeah, in about 2 hours we'll do Flame Trench, and then yeah, that's what I want to do today, guys. If you don't mind, I'm yeah, we didn't get out of the hospital until late last night, so I'm just like, you know, we don't want you to starting to sing ABBA. Yeah, no, nobody wants to hear that. As in all air safety demos, you take your own mask off. You take your own mask, put your own mask off first, then you bother with other people. Family first, then bother about us. Yeah, Frowlin, I know. I know that's the right move. I know that's the right move. Me get it. I don't miss when it comes to actually when the poop hits the fan. I didn't miss last month. Didn't miss again yesterday. The doctors are like, yeah, you were right to come here. Like, she's okay, but now you know. That's at least that's what the doc said to me. So I was like, Okay, cool. I know that I won't miss when it comes to doing that. That's more of a me thing. Like I'm a workaholic, dude. That's what I do. I bury myself in my
Discovery,
work.
go at throttle up.
You know, like, and uncoupling those two from each other is, yeah, my brain's having trouble. I'm not gonna lie, and I don't have, I have no delusions about it. Like, it's gonna take a second to lock back in, dude, but it's okay. It's all right. It's fine. Hey, Bedojo. No problem. Bree first will be here. Yep, yep. Q, did you lose another clip for the Russia? Oh, jeez. Yeah, I signed up for Flame Trench. Bree wanted me to do it. I was like, I told them yesterday when we were sitting in the emergency room, I was like, nope. And this morning she's like, you should do it. I'm like, okay. Okay. Sure. All right, so I sent you a Jared post. We will announce the Artemis 3 crew next week. Tune in because we will also be providing a confidence update on the mission. That's not anything we didn't know though, Trey. Yeah, next Tuesday they on the 9th they will announce the Artemis 3 crew. Yeah. What happened yesterday? Bree had stomach pain creeper again, and stomach pain is what started this whole damn thing. Back when, stuff went down. Like, it's not that this time, like, but yeah, I didn't want to, I wanted to be sure because Bree had surgery, right? And she was, a month ago, she was bleeding internally. You can't tell all the symptoms from something like that. If you have bleeding in your abdomen or something, is just your stomach hurts, right? Like, that's what I didn't know that at the time. I know that now. So when, she came up here yesterday during Space News and she was like, EJ, my stomach hurts. And I'm like, nope, bye. Nope. I'm not even taking the chance. Like, nope. Yeah, so I am never, ever, like, if something, like if Bree's hurt or anybody's hurt, like, I'm never saying, like, no, sleep it off, you'll be fine. Hell with that, dude. And you know me, I'm stubborn. Like, there have been times in the past where I've had such bad stomach pains from, like, eating things that I probably should have gone to the hospital, but you end up passing everything and you feel better. But, up until maybe, like, the last month or so, I'm like, don't worry, you sleep it off. No, no. If it's bad and it stays bad for a long time, for a couple of hours, you should probably go to the hospital. So for it's like stubborn EJ was like, no, I'm fine. You just need some sleep. Just drink some water. Yeah, the hell with that, dude. And it's something I realized over the last month is that this whole meat bag thing, very complicated system. Very, very complicated system. Like, this thing makes a rocket like a Falcon 9 look like Legos. Like, in terms of complex systems. Like, not even Lego Technic, like Duplos. Like, this thing is so ridiculously complicated. There's so many variables and we don't even know all of them. Like, it's like you got to fill in the blanks, which is just like, oh, okay. Everything all right? Yeah, Nighthound, we're good. We're good. I require knowledge of Brimo comfort foods, and I will send them over. I eat strop. If you send strop waffles, we will eat them. So, yeah, I'm never... Something I've learned over the last month is to not be stubborn about that. Going to the emergency room is not that big of a deal, even if you're fine. Like, well, not fine, but like if it's not anything too crazy, that's not that big of a problem. It's just the social aspect of it, I think, is what deters people from doing it. Medicine is like the world's most advanced guessing game. Yeah, Frowlin, it would be like if somebody put me on console on New Glenn. Like, I know what to look for, but I don't know what to, like, on New Glenn or Starship or something. I know what to look for, but I don't know what's a red line condition and what isn't. Like, that very much seems like you know what's going on, you know the gist of it, but you won't know for sure until like it's on a patient to patient basis, which is just like, damn, dude, I don't envy the job that doctors have to do. I respect the hell out of it though. Like that's not an easy what they do in a like if you actually think about like what goes on in a hospital, and I've spent a lot of time in one over the last month, like that's some hard work, man. Some hard work. That and the medical bill. I mean, yeah, Creeper, we have insurance, so it's not that big of a deal. Like that's the other reason why I was just like, yeah, let's go. We already paid our deductible. The deductible's good. I mean, it didn't cost us anything. Ned Jarrett died. Okay. With that all being said, let's jump into space news, shall we? So I wanted to talk about the SpaceX IPO info dump that was yesterday. Yesterday morning, SpaceX posted a bunch of stuff about the IPO, but first, some news from today from the ISS. So this is from Bethany Stevens. Bethany Stevens is she works in NASA communications. And here's what she posted. The Zvezda service module transfer tunnel, known as PRK, has suffered from cracks and leaks for some time and has been mitigated by Roscosmos as much as possible to date. The cracks have always been a concern that NASA watches very closely. My dad is calling me. He's calling me back. I got to touch those. It's not a big deal. All right. NASA and Roscosmos have been working to determine the root cause of the cracks, and Roscosmos manages the issue through operational mitigation measures and periodic partial repair efforts. Following new leaks, Roscosmos has elected to proceed with a more extensive repair operation on Friday, June 5th. Okay. Out of an abundance of caution, NASA has directed all four of the agency's SpaceX Crew 12 members and NASA astronaut Chris Williams to assume an elevated safety posture in the Dragon spacecraft while the repair is underway. We continue to work with our Russian counterparts, along with the rest of the international community that supports the space station, to arrive at a more permanent resolution. And this was posted a little bit after that. Roscosmos has paused Friday's structural repair efforts inside the Zvezda service module transfer tunnel, known as PRK, as more measurements and data is assessed. Given this development, NASA has instructed the crew members inside the Dragon spacecraft to end the safe haven procedures and return to planned operations aboard the International Space Station. We look forward to working with Roscosmos on a collaborative approach to address the leaks. So, if you guys are wondering what and where is Zvezda, give me 1 second. Let me load up something here. I'll show you guys something pretty cool. That update from Jared is about HLS. He replied to an HLS question. That's why I'm happy about it. Oh, okay, Trey. Yeah, we'll check that in a second. How bad is the leak? All right. So first and foremost, dudes, while I'm loading up a picture of or a render of Zvezda, let me just give you a little bit of an overview. All right, and just prime everybody before we jump into this. I want to point out leaks are normal. Okay, they happen. It always happens. Think of it like a ship on the high seas. A ship will always leak water, and it just gets pumped out with a bilge. You're not making a watertight ship. They always leak in some way, shape, or form. Or if it rains, all the water drains into the ship and you get water inside of it. That happens. That's what a bilge pump on a ship is for. Now, honestly, we're not pumping out water in the ISS, right? But it does leak to an extent. It's not a lot. And this leak is not necessarily a lot either. It's just, it really isn't. It's not that big of a deal. But it is leaking more than what the usual rate is. Is it that much more? No, not really, but it's just enough to be a pain in the butt. Give me 1 second. All right, here we go. This is what I'm looking for. So leaks do happen, guys. It's a thing. Here we go. And to show you, I will show you guys my high resolution model of the ISS, courtesy of NASA. This is a very, very high res version of the International Space Station. This is not necessarily an engineering model, but it is a pretty high fidelity model nonetheless. So the ISS has these are kind of the habitable modules here, the ones that are pressurized. The truss segment, forgive the Z fighting, I know it's really bad. The truss segment is an unpressurized segment of the International Space Station. That's where all like batteries and stuff are in the truss. These cylindric modules in the center here, if you're unfamiliar, those are the ones that are pressurized. Now, the station is really combined into two major operational segments. There's the USOS and the ROS. The USOS is the United States operational segment, and it's from pressurized mating adapter 1, which is this piece, that piece right there in the center, forward. Now, in this, we're looking at the station top down. In this render, the left side of your screen is the front of the station, and the right side of your screen is the back of the station. The United States operational segment goes from pressurized mating adapter 1 forward, all the way to IDA 2 at the very front. Now, on the United States operational segment, you have the truss segment, and you have a couple of different modules. You have the Destiny module, or the Unity module right there. Right? Unity is node 1. Node 1 is attached to pressurized mating adapter 1. Pressurized mating adapter 1 is docked to the beginning of the ROS, the Russian operational segment, but we'll get into that in a second. There's a couple of other modules up here. You have the Quest joint airlock on the USOS. That's how you get outside. That's the airlock right there. That's where they egress out of the airlock. And they also store stuff on the Quest module as well, like tools and whatever inside of these lockers right here. So you have Unity here. Unity is they call it a station node. It's a 6-axis node. So you have ports up, down, left, right, forward, and back. Those types of ports are what's called CBMs. There's two different types of CBMs, called just a straight CBM, which a common berthing mechanism. And then there's an ACBM, which is an axial common berthing mechanism. A difference between a CBM and an ACBM is the ACBMs are on the long axis. So that's an ACBM right there, and that's an ACBM right there. Okay? So connecting to the forward part of Unity, you have Destiny. That's the US laboratory. This is, if you like went and Googled a picture of the ISS right now, that's most likely what pops up. The laboratory module with all the desks and all the wires and everything inside of it. That's where the science is done. Now, once again, you have the Quest airlock here. You have Destiny here. And over here, you have Node 3. Node 3 is it's called Tranquility. It's another 6-axis node. It's very similar to Unity, but in this node, you have other things. That's where the cupola module is. So that's where like the astronauts can look out the window. Looks like a TIE fighter. You have the permanent multi-purpose module attached to the front of Tranquility because it's on the side. The axial CBMs are going left to right on Tranquility here in this picture. And yeah, what's in these modules? These modules, the node modules are like multi-purpose. You can do whatever with them. So like Unity has like a kitchen in it. The galley is in Unity. That's where they you cook food. Tranquility has like an exercise room in it, and it has the head, the toilet's in there. And then obviously, actually, the toilet is right by the cupola module. It's actually right here. Now, this model is a little bit old. There is an expandable module attached right here that's used for storage called Beam, the Bigelow Aerospace Experimental Module. Bigelow's since gone under. NASA owns the module now. But yeah. And then up here, you have the Z1 truss segment. Z1 truss segment has your control moment gyros in it. You have your gyroscopes there that are used for attitude orientation. There's obviously foreign redundancy there. That's what keeps the station parallel to the ground. The station kind of flies like an airplane around Earth, so the surface is always that way. The bottom of the station, the cupola, is always facing the ground. And if, like, you think about an airplane flying, the truss segment is the wing. Now, it's not flying through the air, it's in space. It's just oriented like an airplane. So the front is up here at IDA2, and, the truss segment goes port to starboard, etc., etc. Now, up at the front of the USOS, you have node 2, which is Harmony. It's another multi-purpose node. In this render, it has the Canadarm attached to it. That's the Space Station Remote Manipulator System, or SSRMS. And in this model, it has Dexter attached to the front, which is an attachment piece for the arm, which basically gives the arm fingers. Dexter is made by the Canadian Space Agency as well, and so is the arm. Now, the cool thing about the arm is that it can actually grapple around the space station. Anywhere you see one of these kind of three teardrop grapple, this is called a grapple point, the arm can attach there. And the cool thing about the arm, just in case you didn't know, is that you can monkey bar around the station. So, like, it can grab one point and be powered from that point, and then receive like a spacecraft, like a Cygnus, and then take the Cygnus and dock, and then uncouple from the Cygnus, grab another part of the space station and let go. And then this is the end of the remote manipulator system. You can flip the inverse kinematics on it. It's really cool, actually. Really interesting piece of kit there from our Canadian friends. The other thing is that up here you have the MBS, the Mobile Base Station. A lot of people don't know the ISS actually has a tram. There's a train built onto the ISS, the Mobile Base System. You can attach the arm to the grapple points on the MBS right here. And this is where you store extra arm components, like extra grapple end or latching end effector and grapple points. And it's a train. This is an electric locomotive, and it has a car in the front and a car in the back, and it does this. The MBS can go move down the rails on the truss segment. Just like a model train, the tracks are quote unquote electrified. Not a lot of people know that. There is a train operating in space, and it can go all the way to the end of the solar panels, or all the way out to the batteries in the solar panels on either side. So up at node 2, you have a bunch of different stuff attached to it. You have the Columbus module, which is the European ESA's, the European Space Agency. So that's ESA's module for doing ESA things. And then you have over here the Japanese experiment module, the GEM, and then Kibo, which is a storage module here. This is all contributed by JAXA, the Japanese space program. The GEM has the Japanese experiment module has the open experiment platform. It's called the exposed facility. And what you can do, it has a little mini arm on it, and there's a small airlock to put small, not human size, to put science experiments through, and the arm can pluck the science experiment out in a little case, and it can attach it to the exposed facility. Super freaking cool. So if you're doing a science experiment that needs to be exposed to the vacuum of space, there you go. Pretty cool, right? And then you have the Japanese storage module called Kibo up here. That's just additional storage for experiments or whatnot. Now, that's pretty much comprises the USOS. So that's the side that the US and international partners control. So us, the Europeans, and Japan kind of control the USOS. Primary controller of the USOS, though, is Mission Control Houston. So Houston, they're the ones that are overseeing it. So that's NASA Flight Operations. They primarily oversee the USOS with the European mission control and the Japanese mission control assisting. They're all kind of linked together. I mean, we're linked together with Russia's mission control too. But up at the front here, you have two what's called PMAs, pressurized mating adapters. These are from Shuttle Era Vintage. I mean, the whole station's from Shuttle Era Vintage, but we'll talk about that more in a second. These pressurized mating adapters were what the shuttle could dock to, primarily PMA-2 up here, pressurized mating attachment 2. PMA-2 came up on the first ISS shuttle assembly flight, so STS-88. It's so the shuttle could dock to the station and then add components to it, right? Now, after the shuttle program, these things, international docking adapters, were attached to the front of the pressurized mating adapter. This adapts the shuttle's docking port, which is called an APAS, Androgynous Peripheral Attachment System, to the NDS, or NASA Docking Standard, which is based off of the International Docking, or NASA Docking System, which is based off of the International Docking System Standard. Huh. Yes. ACBM to PMA to APAS 95 to IDSS. Yeah, I know. And you thought it was a pain in the butt finding an adapter to get your printer to work. So that's the USOS side of the station. Quick high-level overview. Now, over here to the Russian side of the segment. Attached to PMA-1 at the front, or at the back of PMA-1, front of the ROS, you have Zarya. Zarya is a, what's called, in Russian, it's called a functional cargo block, or FGB for short.
Discovery.
Zarya is batteries. It's battery electrical power for the space station. This functional cargo block is just caked in batteries. The cargo block is basically just generic space station module. Like, it's just a pressurized segment. You could put basically whatever you want on the outside. Functional cargo blocks. Hey, Mufasa 53 and Tatum with the 3-month resub. Where do they lob CubeSats from? The gem? Or any specific dispensers, Lava? Before I continue talking about Zarya, there's on the sides of the truss segment over here, there are fixtures for attaching pallets. Right here is it's ELC1, but what that is a leftover shuttle pallet. You can just put CubeSat dispensers on this thing and then just yeet out CubeSats whenever you feel like it. One time it did it by accident, which is still pretty funny. But yeah, on the top and the bottom of the truss segment, they have attachment points to be able to bolt shuttle pallets to. That's so the shuttle could bring up whatever experiments and you could just put whatever you want on the top and bottom of the truss segment. I'm telling you, the truss segment design is pretty damn smart. Whoever thought of this really, really knew what they were doing. It's originally derived from Space Station Freedom back in the day. They had a lot of time to think about this. It's really, the honest truth is that this is really, really good if you have a space shuttle. It's not the best if you don't have a space shuttle, just putting it out there. So yeah, there's shuttle pallets that are up here that have experiments on them. And then you can attach experiments that are built off of shuttle pallets to the top and bottom of the truss structure. Like that one right there. That's the AMSO2 Alpha Magnetic Spectrometer that launched on STS-134. One of the last payload deliveries to the ISS. Well, the last payload delivery. That was the last assembly mission. And then STS-135 was a resupply mission, if anybody cares. But yeah, this whole truss segment is actually really cool. The shuttle could come up here and you could just pull pallets off and put new ones on with the arms. It's really freaking smart, actually. But yeah, going back over to the ROS, these functional cargo blocks, this is Zarya. It's a functional cargo block. The functional cargo block is derived from the Soviet TKS spacecraft. TKS was a spacecraft that was supposed to launch on... It was supposed to launch on Proton back in the day, and it was seen as a replacement for Soyuz. So it's a capsule shape, right? You have a capsule with a service module behind it, think like Apollo, but the service module behind it is also a space station module. So you launch the whole thing on Proton, right? And yeah, you could put whatever on this thing. You could put batteries, you could put cameras. The Western equivalent would be the Gemini Manned Orbiting Laboratory, so Gemini MOL. In fact, if I had to guess, they probably built that because of Gemini MOL or vice versa. Gemini Manned Orbiting Laboratory was a space station module and service module attached to the back of a Gemini capsule. So the idea here... Sounds like a Detroit. The idea here... I have Starbase Live on in the background. The idea here is that instead of launching a space station module and then launching your capsule and then docking them to each other, right? You launch it all in one shot, and this has a shelf life, right? And then when the shelf life runs out, you just deorbit the whole thing and then detach the capsule. Could a future modification of Starship take advantage of the trust system? It's probably better if we just build a new one, SCJ, but I will get more into that in a second. Oh god, oh my god, that model. Lewis, it's NASA public. I found this on NASA's website. Yeah, one time. If not, it's a freaking disgustingly big 3D model, and yeah, Lewis, it's a lot of... Here, let me go through the hierarchy. I think it's like 3 million polys or something. The USOS in this model is very, 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 very detailed, right down to the anodized aluminum handles for extravehicular activities. Anytime you guys see these kind of golden bronzish handles, that's where astronauts grab to move around during a extravehicular activity, but that's another story. Also, one of the communications relays is upside down.
Go at throttle up.
The Z1 Trust segment, guys, just on a side note, has a edit. Where's the center pivot function? Ah, there we go. Oh, nope, undo that. Nope. Center pivot. I don't know why that thing is all... That dish should be facing up, but it's not. So, you know what? We'll just leave it clipping into node 3. It doesn't matter. So, I'm getting to it, Martin. Hey, Vanguard. Any new rockets to review today? Sure. So, attached to what's called the Nadir, NADIR, which is down relative to primary station orientation, is the this is the Rasvet module. Rasvet was brought up by the space shuttle. It's a Russian component that was attached with the shuttle. And what Rasvet is a docking module. So it has Russian APAS on one side attached to a 4-axis node here. That's on the front of the functional cargo block. The FGB, like I said, it was originally built as a spacecraft, the TKS, but then the Soviets decided they wanted to keep flying Soyuz, or I think it was actually switched to Buran Energia, but that's another story. So what they did was they just, instead of launching a spaceship with this, they modified it for the androgenous peripheral attachment system, and then, put docking adapters on them, on the functional cargo blocks to get them so they could have Soyuz dock to it. So anytime you see this cone right here, that's called an SSVP. That's the Soyuz probe and drogue system. It's a Soyuz docking port. So Rasvet is a docking adapter to accept Soyuz or Progress spacecraft. Really, really, really fun fact about Rasvet. Rasvet is a Mir docking module. Back during the Shuttle Mir program, they needed to make an adapter to, so the shuttle could dock to Mir, right? They needed to make an adapter piece. Rasvet was made from the spare. They made two. Because back in the day, we were a little smarter about how we do spaceflight. You always make a spare just in case. Always. Don't ever just make one. Making one is stupid. Like having one launch pad. Dumb idea. So Rasvet is a shuttle Mir docking attachment. It's just, Yeah, it's modified for Soyuz, but that's what it is. And the crazy, crazy, crazy part about this, if you really want some 6 degrees of separation here, the shuttle,
go at throttle up.
the shuttle Mir docking attachment is derived from the Apollo Soyuz test project docking adapter. How's that for 6 degrees of separation? That's pretty cool. Hey, Fed Up. 1 is none, 2 is 1. Bingo. Was Unity first launched or was Rassvet first launched? I'll get to that in a moment. So, on the back of Zarya, you have the Zvezda. Zvezda is the Russian word for star, and this is the service module. So if Zarya, the functional cargo block for Zarya was modified to be the battery and electrical storage, and then just miscellaneous cargo storage on the pressurized volume, Zvezda is your service module. So Zvezda, the type of module that it is these are a DOS module. This is the DOS modules, I forget what it stands for in Russian. DOS modules are derived from the Salyut program, which is the Russian word for salute. The Salyut program was the Soviet space station program, but it wasn't a space station program. What they were really trying to do with these is field manned spy satellites. That's really where it's derived from. Once again, similar to Gemini manned orbiting laboratory, same idea. But the DOS module is a more purpose-built space station module. It is derived from Salyut. This particular one is DOS number 9. It was the 9th DOS module that the Soviet Union made, with the first one going back into the middle of the space race. Salyut 1. Now, this is important to understand, all right? Just for some context here. And this is why I wanted to go over the whole station with you guys. These modules, the DOS modules, and so they were from the Salyut program. Those modules were not designed to have a very long shelf life. The Salyut program and subsequently the Almaz program that came with it. The Almaz was a military installation space station that the Soviet Union tried. Fun fact, it had PDWs on it, point defense weapons like the Expanse, and we really quickly figured out why you shouldn't do that in space, the Americans and the Soviets. Yeah, Almaz had a cannon attached to this, like a gun, like a point defense gun attached to the side. If anything got near it, they could shoot it. Fun fact. Gee, I wonder why they did that. Were they worried about something coming near the station? Probably. Saying. So these DOS modules are not designed to have a long shelf life. From the 60s all the way into the 80s, so over 20 years, the Soviets had they had 7 of them. So Salyut 1, 2, 3, 4, 5, 6, all the way up to Salyut 7 in the early 80s. Salyut 7 was DOS number 7. And there's a really interesting story about Salyut 7, how the Soviets were scared that we were going to come take it with a space shuttle. I'm serious. I don't know if there was any truth to that. Probably not, but you never know. Salyut 7 had broken. It had malfunctioned in the early 80s. And the Soviets were worried that we were going to, I don't know how, I don't know if this is true. I have no idea. I can't confirm nor deny. That they somehow got wind, or somebody whispered in their ear, could be misinformation, could have been real, I don't know, that we were going to use the space shuttle to go and grab it. So what the Soviets did, spooked by that, is sent 2 cosmonauts up there in 1985 to a literal offline space station and had them fix it in situ, which is absolutely 100% insane. It's very much the Soviet Union's Apollo 13. It's a very crazy story. And you know what? They did it. It worked. They fixed it. They somehow got that pile of crap DOS module online, and they fixed it. DOS is long duration orbital space station or orbital station. Well, there you go. That's cool. Yeah, the Russians made a movie about it. It's actually pretty crazy. Yeah, that sounds right, Panta. I couldn't remember it off the top of my head. No, that was only in the movie. Almaz 3 had the gun. Yeah, there you go. Mm-hmm. Durable. DOS is durable orbital station? Oh, okay. Well, that works. Is there any particular reason why most of the Russian modules are mounted along the nadir, while the USOS is moving more along the local horizon? Their modules have solar panels on the sides. Straight up, you're not going to put a module in blocking your solar panels. Now, once again, fellas, look, I'm just trying to say this how it is, all right? I'm not trying to endorse anything or look, the Soviets knew how to make space station modules and they knew how to make spacecraft, all right? Like they're pretty damn good at it. These DOS modules are pretty and the functional cargo blocks are pretty damn good designs, all right? Got to give credit where credit is due. I mean, I personally like this whole thing going on over here because space shuttle, but, you know, a little bit biased. So, after the DOS, the Salyut program concluded, the Russians switched to a more modular style program. They pioneered what's called a modular space station. A modular space station came in the form of Mir, which is the Russian word for unity. The Mir space station was built in the 80s. They were building Mir when they sent the dudes up to Salyut 7 to fix it. And Mir had converted what Mir was. You had your Mir core node. And the interesting thing, Lava Eagle, is that Mir had a 6-axis docking node and it had modules coming out of either side. So Mir was a combination of the Mir core module was a DOS, and then it had a bunch of functional cargo blocks attached to it. Yeah, it had a bunch of FGBs. Now, we'll talk more about that in a second. So attached to the Zenith, which is the top of the Zvezda module, which has a 6-axis node at the front, you have the Poisk. Poisk is a Soviet docking adapter. It's a docking adapter for Soyuz. It has an SSVP on it, and it is also the airlock. Now, for the ISS for the longest time had 2 of these. Notice that the name up there in the channel box is MRM2. There was MRM1. It was called Pirs, which is the Russian word for dock, right? Pirs was down here. It was on the nadir of Zvezda, right? And they got rid of it. In 2021, the Russians got rid of it to install this, another functional cargo block called Nauka. Nauka is the Russian science module. And then on the bottom of Nauka, there is another 6-axis docking node called Prichal, but it's not in this. It's not in this render. Prichal just looks like this, but bigger. Hey, CosmoQuest, thanks for the raid. Mir means unity. Soyuz means union, Kens. Soyuz is the Russian word for union. So it's the union capsule if you wanted to call it in English. Yeah. The docking of Soyuz 13 was insane. Salyut was tumbling along 2 axes, so the movie... Yeah, no, Kai, the Salyut 7 mission is bananas. Have you guys ever seen Interstellar? Come on, TARS! Like, matching the rotational rate of a station to dock to it? That. Literally that. Where the hell do you think they got the idea? This guy named Spam Risk keeps calling me. I don't know why he's obsessed with me so much. Sorry, phone was going off. I keep my phone off silent just in case Bree needs me. Nice, Ellie. That's cool. And Cosmo Quest, thank you for the raid. I appreciate it. That's my brother. He's trying to give you more money. Oh. Spam Risk. Yes, very Dutch name. Yes, Risk is very, very, very Dutch. Yes, very good name. Why does he want me to buy spam? I don't get it. There were plans to recover Salyut 7 with Buran, so shuttle might have been able to carry it. Kai, I think, personal, honest opinion, Cold War espionage aside, this can't fit. It's too big. And even if it did fit inside of a shuttle bay, I don't think those solar panels are designed to fully retract. Now, the solar panels on Zvezda and Zarya can retract, but they can only retract so much, like that. They can't like fully retract like the solar panels in KSP. It doesn't work like that. So even if we did go and get it, or Buran went and got it, there's no way you'd have to cut the solar panels off to get it to fit. And you cut some of the antennas and whatever else was attached to it to get it to fit. DOS modules are gigantic, guys. A school bus could fit inside of one. They're huge. They just don't look like they're huge when you see interior pictures of the ISS, because there's stuff in there like the things that you need to keep in there to stay alive. Yeah, this is a huge volume for a space station module, at least like even nowadays. That's pretty big. Keep in mind that an entire DOS module with its solar panels folded inward could probably fit inside of Starship's payload bay, just for some scale. That's how big Starship is compared to some of these freaking modules, but that's another story. Okay, so yeah, attached to the bottom, or the nadir of Zvezda, you have Nauka, which is another functional cargo block like Zvezda. I added it to the model here. Yeah, the Chinese modules are based off of DOSs. They use the DOS segment for Tiangong. Yeah, I added this. I just went into the hierarchy and took Rasved off, copied the functional cargo block, and made Nauka. This isn't an exact render of what Nauka looks like, but it's okay. So let's get into what's going on. There are leaks. Where are the leaks? They're like, once again, I want to precurse this with, look, the station always leaks. It always leaks. You're going to have small ones. It happens. That is normal. The big problem here is the leak rate. Some of the leaks inside of Zvezda have gotten to be a little bit higher than what we're kind of comfortable with, to the point where, you have a deficit of air, and they can send up more. You can always send up more air with like a module with a supply vehicle, but the leak rate is enough to be a little bit of you're kind of cutting it close between supply missions, right? Now the ISS does recycle a lot of the systems on board. It does recycle. It recycles water. There's no P dumping system like the Orion capsule. It recycles it. And it does recycle air in the form of CO2 scrubbers, which do need to constantly be changed out. They can add more air to the system if needed. So, where is the leak? The leak is in the vestibule on the very back of the Zvezda module. It's right here. There is a pressurized volume right here. It's similar to the docking vestibule on the IDAs, not in design, but in function. The leaks are coming from this piece back here. See where it's tapered? So this piece, I'll just make a primitive cylinder and bring it over here and show you what I'm talking about. It's a cylinder. So in terms of pressurized volume, you have a piece here that kind of goes in. Where the heck is this piece relative? Give me 1 second. Focus the camera on it. Please hold. There we go. Nope, it went around. There we go. All right, so there is a little bit of a pressurized volume here. Let me just kind of make the cylinder look right and go from here. Go Up there. The SSVP right here has a pressurized piece behind it. That right there, this pressurized volume is part of the airlock system. This is a pressurized segment, and then there's another hatch behind it. That's the PRK that Bethany Stevens is talking about. All right. These models don't have an interior in them, but that's what it would look like. So let's go back to non-wireframe view. Did I make this? This is a NASA model. I did not model this. No, there would not nearly be that much sea fighting if I modeled this damn thing. We could use it to make nice models for Kerbal. I've thought about doing that. These are way too high resolution for KSP. It would quite actually fry your GPU if you tried to put it into KSP. Or at least just break something. But yeah, we could use this to get the shape of the modules and go, like truss segments and whatever. Bugs everywhere. So, and once again, guys, this is not an engineering model. I don't want to be like, oh, I'm better than NASA. This is not an engineering model. This is used for presentations, like what I'm telling you about. This is most likely converted from the engineering models, but I do believe I had to, this was like in a, I don't even remember. I had to rip this from another CAD program. It was not designed to work in Maya. I had to convert it to an OBJ and then import the OBJ into Maya, and even then it just made an absolute mess of the edge flow here on the truss set. Like that's just awful. That's what happens when you rip and convert 3D from one CAD to another. Look, that's just, that's not great. You have a 3D printer, right? Yeah, of course. Do we need to bring back Kerbal Space Station again? Flame Trench? I don't know. Who knows? Anyway, so the leaks are coming back here. This is the, so I want to add a couple of things here. That's where the leaks are coming. Leaks happen. It's just the leak rate is above what they really want it to be. All of this is done out of an abundance of caution. You'll hear that from NASA. We're doing it out of an abundance of caution. What likely is going on is, say it's leaking like 3 PSI a week. It's leaking 4 PSI a week now. Like, you know, leaking PSI is not really the right unit of measurement there for flow. PSI is not flow. I understand that. Like, it's the leak rate is above what they need it to be. Now, here's the thing. If you go and look at that damn thread, right, that Bethany said, you get a bunch of people down here that really have no idea what they're talking about. Look, dudes. You could say that this is my opinion, but I'm just going to the reason why I wanted to go through a little brief overview of the history of the ISS with you guys is the fact of the matter is that this DOS module, DOS-9, is a Soviet module. DOS-9 and this functional cargo block, Zarya and Zvezda, and Nauka are all leftover components from the Soviet Mir-2 space station program. Just like all of these components over here on the United States operational segment side are leftover parts from Space Station Freedom. Meaning that most of these modules that have been in space for, well, somebody asked, the first module that went up there was Zarya. That is the core node of the ISS, technically. Zarya was launched in 1998 on a Proton rocket. That was the first one. And then the space shuttle brought up Unity, PMA-1 and PMA-2 in 1998, right after that. Zvezda, the DOS module, which is of Soviet vintage, was launched in 2000 on a Proton rocket. Nauka was launched in 2021 because after the Soviet Union collapsed in the early 90s, they didn't have the budget to finish it and left it in a building for 20 years. Well, 30 years. The Russians put it back together. They found FOD inside of it. The Russians went through a very hard cleaning campaign in the late 2010s to clean out this thing and make sure the pressure vessel was working. And then they did end up launching it in 2021. And it almost spun the space station out of control like in Interstellar, but that's another story. All right, so today, a year ago, Elon decommissioned an undecommissioned Dragon, and that's great. Yeah, Elon's whole political side quest was not, yeah, I don't think that was fortuitous, but whatever. He did it. But anyway, yeah, I don't want to talk about that. TLDR, the space station is very old and at the end of its lifetime for a new one. Ace, that's what I've been saying for a number of years now. These modules are old, and on top of them being old, the DOS modules were not designed to be up there for 26 freaking years. In fact, as much as I hate saying it, the Russians have been saying that this thing will not last. It's very unlikely that it will last as long as we want the ISS to be up there because of this. They've been saying it for some time. And yet we just sit here and keep extending the life of the space station. Now, once again, why? Why are we getting leaks on these modules? What's going to cause this thing to leak? Is it just because it's old? Well, yeah, it being old has a lot to do with it. But another important thing to understand is that Zvezda is the service module for the space station. This is your power and propulsion element for the ISS. If the ISS needs to change its orbit, if it needs to do maneuvers, the Zvezda module is what's doing it. None of these other modules have propulsion systems on it. Well, Zarya and Nauka do, but you do not want to outgas when you're attached, when you have a module behind you. That's probably stupid. The Russians have most likely inerted the propulsion systems on these modules, because that would be stupid to keep them fueled. And like I said, look, I know people like bashing the Russians. I know there's current events going on. Look, these are good modules. I'm not going to sit here and be like, no, they're not because I don't like them. No, these are good modules. The reason why Zvezda is broken is because it's 40 freaking years old. This thing is of Soviet vintage, and it's your propulsion system. Now, to save on fuel, DOS modules can also be boosted by spacecraft. Okay? Important to understand. Progress, or Soyuz, can attach to the back of this thing. And not only can they attach, they can transfer fuel into Zvezda. Yeah, they can move fuel from a Soyuz or Progress into Zvezda. It's one of the only, I do believe it's the only on-orbit propellant transfer system that has been implemented successfully. Now, keep in mind, the propellants that they're using are hypergolic. So, yeah, it's kind of easier to do that. You just need a pump. It's not like transferring cryogenic fuels like with Starship or with Blue Moon Mark II, a little more complicated because you have to move stuff under pressure, and it's boiling, and the boiling can, boil off, can overpressurize things, etc., etc. It's not as easy as transferring hypergols around. But understand, if you're pushing with a Progress capsule to boost the space station back here, guess what it's going to do? It's going to put load cycles on your docking attachment system, right? They don't know for sure if that's what's going on, but also at the same time, this Zvezda module, DOSs were only designed to be boosted by, have like maybe, I don't know, 100 tons of module in front of it. Maybe on a good, not even that. Mir wasn't even close to that. Mir was a very small space station comparatively to, or about half the size of the ISS. And they did use their DOS module there to boost the space station, right? But you're putting load cycles every time you boost on this thing with a progress capsule. Every time you use a progress capsule to boost the entire space station to a different orbit or use it for collision avoidance, etc., etc. And not only are you putting load cycles on this, you're putting load cycles on a module that's frankly not designed in the long duration to move a 400-ton space station that's the size of a football field. Guys, to be quite honest, test credit where credit is due. The Russians have kept that thing working pretty well considering the circumstances. Now, with that being said, it's made out of aluminum. Anybody here that works in airplanes know that an aluminum airframe or an aluminum pressure vessel has a shelf life. It has a shelf life. It's only going to last so long before aluminum will just crack and start fracturing. Stress fractures in aluminum are absolutely a thing. Aluminum cracks like concrete does. And the more cracks you get, the worse it's going to get. Now, with all that being said, it seems like we got another crack here. Now, how did the Russians fix it? Well, space bubblegum. Press the leak. But these are microscopic cracks, too. You got to find where they're coming from. That's not as easy as you might think. We're talking about a crack that we wouldn't be able to see. So what the Russians have to do is fill this thing with smoke and figure out where the crack is, see where the smoke goes, right? Because it is leaking. It's not an easy problem to solve. And we will help them, like obviously we're going to, because it's our space station too. But yeah, the short story, guys, if you want an explanation for why it's leaking more, dude, it's 40 years old. This module is older than most viewers. Heck, it's older than me. This thing was made in the mid-80s for the Mir 2 space station. It was built during the Soviet times. So like 87, 88, it's basically my age. And it's been in space for half of my existence. So it was a module that was made in the late 80s under the Soviet Union. And then the Russians launched it in 2000, right? And then it's been up there since. It's been up there for 26 years. And it's boosted this 400-ton station I don't know how many times, guys. It's just old. Like, I know people want to harp on the Russians, be like, oh my God, they suck. Like, it's old, dude. What are you going to do? Heck, the whole station is old. Guys, these, and it's not just those modules. The reason why I went over the USOS and said, like, look, this is all Space Station Freedom vintage. Same thing, dudes. These modules were made in the 80s. All of them. Like, well, not all of them. They were designed in the 80s and built into the 90s and all the way into the 2000s. But this is all a Space Station Freedom design. This is what a space station, this is what a high-tech space station looks like in the 80s. It's old, dudes. And I'm not saying get rid of it, certainly not without a replacement, but yeah, you want some context as to what's going on here. It's old. Zvezda is old. Even the Russians have said, like, look, this thing is not going to last very long. And if we can't dock a progress to this without it leaking, we can't resupply the service module, and then that puts a shelf life on the entire ISS. Now, I know what people are going to ask. Can we just detach? No, you cannot. That's your propulsion system. That would basically dead reckoning or dead stick the ISS. That would be a very bad idea. Can't detach. I know these are all modules that are linked together, etc., etc. These Zarya Zvezda, Node 1, Destiny, and Node 2 are basically conjoined at the hip. You cannot. There have been multiple EVAs to wire them all together, to structurally put them together. Like, see, if you look at all the wiring here on Node 1, Node 1 is basically a gigantic DC to DC inverter to adapt the Russians' electrical systems to the USOS electrical systems. If you uncouple that, the whole station will just... Now, on the Russian side, if they decoupled, they would have no power. Those solar panels on Zarya and Zvezda and Nauka are not enough to generate. They're not enough to generate power on their systems to keep them producing science. Or well, I mean, you could habitate the station, but once again, all the electrical systems are conjoined at the hip. You're not doing that. It's not going to work that way. They might be able to uncouple them, maybe, but I don't know why you'd want to uncouple some old Soviet modules that are at this point almost a half century old. I don't know why you'd want to do that. Wasn't the OG Space Station Freedom thrust system based on thrusters out on the ends of the main truss? Yes, that's correct. And Aqualex, this is why I wanted to do the high-level overview to cover all the bases. The reason why there's attachment points here, for shuttle pallets is because during Space Station Freedom, so this is before the ISS program, what they were going to do is attach the power and propulsion systems. The PPE for Space Station Freedom was going to be out on the truss segments. And they were going to basically be a reaction control systems that are attached on shuttle pallets here. These systems, these pallets here, hold up, here, and here were supposed to be your propulsion systems. They would attach them and integrate them into a thruster system so you'd have propulsion. We scrapped that idea. We scrapped those modules when, somebody in the 90s is just like, oh yeah, use that old Mir module. That'll be fine. That's good. That's good enough for power and propulsion. We could save money doing that. You like saving money, don't you? I'm a big 90s guy. Here, why don't I just take your job? You know what I mean. I like how you were saying Zarya and Zvezda. Yeah, and Spasiba. I take my time to get the pronunciations right. Because that's what they're called. That's their name. If somebody's named Jim, you don't sit there and call them Bob. You know what I mean? Jim Gothenburg. Yeah, okay, Stevie. That's one exception. I don't know how to say that. I know how to say Zarya and Zvezda. What about Jam? I don't know. I know another guy named Greg. You want me to call him? The difference between the ISS and the Chinese station is night and day. Yeah, one man. So first of all, a lot of okay, and I'm not saying this to be like, man, their space stations suck. Tiangong is heavily derived from Russian DOS segments and parts of the USOS that China looked at and said, oh, that's a good idea. Maybe we should do that. I'm not trying to stir the pot like it is. Like I'm sorry. Like I don't. Facts bother you. That's not my problem. Zarya is 32 years old from the start of the build. Same for Nauka. Zvezda is 40 to 45 years old. That's what I mean, man. The leaks are coming. Deadbringer, people are making a big deal out of this and want to give the Russians crap. Dude, the module that's leaking is a half century old. Almost a half century old. All right. I'm willing to cut a little bit of slack. It's lasted a good time. And this is, since all these modules are basically conjoined at the hip at this point, you're not detaching them to make another space station. That's not a thing. You can't do that. They're all kind of hot wired together to work as one contiguous unit. Simultaneously, all the people that did work on this thing to make this one contiguous unit, there's no chance that they still work at NASA. This space station is old. People that designed this are retired, long retired. Right? Not to say that the technical expertise isn't there. You could probably try. But, I wouldn't say I'm using it, J-Speed, but yeah. Also, the crew cab coronet is requiring an entire rebuild from the ground up to get it to work again. Too bad no one planned an upgrade and replacement path. Yeah, well, Jim, that feeds to a whole thing that I've been talking about for some time that, NASA needs to figure out a long-term sustainable architecture, and I don't want to get on my soapbox there. One man, sorry, your point is that the ISS shows a lot of wear compared to the Chinese station. Theirs will also wear over time, and they have had problems as well. Yeah, I know. The Chinese station is not wearing out because it's newer, and it's also smaller. Tiangong is basically 3 or 4 DOS modules linked together. They're not DOS modules. I don't know what they call them. bear with me here. If they brought back the shuttle, do you think we could build a new station with it? Personally, Ramalot, if... Okay. Do I love the space shuttle? Yes. It's an awesome machine. And you can build stuff like this with it. If you don't have a shuttle, and you don't have a system that can constantly go up and go down, add modules, take off modules, etc., this type of station makes absolutely no sense. Since we're going back to pods for the time being, it would be much wiser to do something like Skylab. Skylab would be a very good alternative to this. The Skylab station was about the third of the size of the ISS in terms of habitable volume, and it was launched in one launch, comparatively to the ISS, which took 35 shuttle flights to make. 35 shuttle flights from 1998 until 2010. Over 12 years. Just add an arm to Starship. There you go. At the very least, solar activity is now decreasing, so fewer reboosts will be required until 2031. Yeah, solar maximums and minimums. If they ever need to deorbit the ISS quickly because of this, I heard Starliner is also available. Rip. Rip. Hey, Vidless, what's going on? So yeah, guys, that's kind of your overview of what's going on with Zvezda. The PRK airlock is leaking. It's leaking because it's 45 years old and it's been on orbit for 26 years. It's been on orbit for a long time. I'm not dropping frames on my end, Shaw. But yeah, that's a little bit of an overview of the ISS. It's an awesome machine. It really is. And I don't want to be that guy. And we'll talk more about this on Flame Trench in a little bit. But honestly, just make something else. Just make something else. This thing is old, man. It is old. And some of the modules are new. Like Nauka was launched in 2021. It's pretty much brand new. I mean, it was sitting in a hangar for like 40 years or 30 years or something. But we do have new modules on it. That means dick if your propulsion system doesn't work. That means nothing. Oh, great. Look at all these modules you attach to that you can't steer. They got a word for that. It's called orbital debris, or a phrase for that. It's called orbital debris. Yeah. Unguided stuff flying through space with no guidance or propulsion system is called debris. And we do not need a 400-ton piece of debris floating around in low Earth orbit. Can you see why that would be a bad idea? Hey, Missy, what's going on? I honestly think as long as we're using rockets for the time being, a Skylab style space station, or honestly just a Starship with a space station built inside of the payload bay. That, I mean, Starship is already designed to stay up there for a long period of time. With propellant transfer, etc., you put solar panels into the mix there, it can stay up for even longer. And honestly, just use starships like Skylab. So Skylab was a gigantic dry workshop that was made out of a Saturn V third stage. I'm just trying to get you guys a picture of it. This is the best picture. How are they going to deorbit the ISS? The ISS is going to be deorbited by a bespoke one-off, highly modified Dragon capsule called the US Deorbit Vehicle, or USDV for short. And it's going to attach to the front of the ISS and fire its thrusters. It is a Dragon. The renders make it look like a Dragon capsule with a service module attached to the back. And the service module has propulsion systems on it. Those propulsion systems consist of basically like 30 or 40 Draco thrusters. They're basically just going to take a bunch of dragon thrusters, put it in the trunk of a dragon, and give it enough fuel. It's not super Dracos. They're just Dracos. They're just basically going to put a lot of RCS on the back of a highly modified, non-reusable dragon capsule and bring it down. So, I honestly think it would be better if we just sent up a starship in the future, put a habitable volume inside of Starship's payload bay, and then put a docking port on the top. You know, Starship opens up its payload bay doors, you attach a Dragon or a Starliner or anything to it, right? And you have an on-orbit space station. And instead of resupplying that space station, instead of having to resupply it and resupply it and resupply it, when the station runs out of material, runs out of like consumables, I mean, you could just send you could send a supply vehicle up there if you want, or you could just bring it back down. Just bring it back down. Deorbit, get the Dragon off of it, deorbit the thing, or an Orion, whatever. Deorbit the thing, bring it back down, re-equip the station, swap out all the science, and send it again. This is not a far-fetched idea, guys. This was definitely done during the shuttle program. It's called Space Lab, where they basically just put an ISS module, not an ISS module, but they put a gigantic pressurized volume inside of the shuttle's payload bay and an extended duration orbiter, or EDO, pallet in the back of the shuttle's payload bay, and the EDO just carried extra consumables for the life support systems and the power systems. And the shuttle, they let the shuttle stay up there for a little while, and basically it worked like a little mini space station. They did this during Shuttle Mir, and they did it throughout the 80s with the shuttle program with Space Lab, and then they had Space Hab after that, and they used that all the way into the 2000s. The reason why they used it into the 2000s is because the ISS was still under construction. Once the ISS came up, there was really no need to do that anymore. Why the long tube? Good question. Anybody know? Columbia's last flight had one of those aboard. Columbia was on STS-107, was carrying the EDO in a Space Lab module, yes. Center of mass. Yep. The reason why there's a tube going back to the module... Hey, Lev, thanks for the resub. The reason why there's a tube going back to the module and why everything is kind of stuffed into the back end of the shuttle's payload bay is because the shuttle needs to fly and it needs to land like an airplane. So mass distribution is key, like an airplane. It won't fly very well if this big heavy module is sitting up here by the flight deck. So for mass balance and mass distribution, they put this tube back there so you could get into the module. Yeah, nose heavy planes fly okay. That's not what you need. So the shuttle has a center of lift that's biased towards the rear, guys, because it's a delta wing. Now, it's a straight delta wing, so the center of lift on the shuttle is like back here somewhere. Why? Why is it back there? It's because the center of mass is back there. Why is the center of gravity on the shuttle so far backwards? Don't tail-heavy planes fly poorly? Yes, they do. The reason why the shuttle's tail-heavy is because you have 3 Mack trucks worth of engines back there that you have to lug back down from orbit. That's why. So the shuttle always had a rearward center of mass bias. And people always say the shuttle flies like Dookie. And the reason why it flies like Dookie is because the bias is towards the back. If you are familiar with Porsches have the engines in the back. They're susceptible to a thing called snap oversteer, where the rear end comes around. Same idea, but with a plane. How dangerous was the space shuttle compared to today's standard? Wes, that's a good question. The shuttle is, I would say, well, statistically, it's more dangerous. Yeah, statistically, it's more dangerous. Today's stuff is way safer. But, Wes, here's the thing. If you're looking at it like if you're just looking at the stat, like if you just Google like how safe was the space shuttle, right? That's what'll pop up. It'll say that, oh yeah, today's capsules are much safer. Today's capsules are much safer. And they are. They are. They're safer because they do less things. Okay? So think about it like if you have a Cessna 170, Cessna 172, which is single engine, air cooled, 4-person airplane, right? Right? And think about that like if a 737 compared to like a Cessna 172. Anybody that knows anything about planes knows that why are you comparing those two planes? They are completely different. One does way more than the other. Well, that's the idea. The space shuttle, I would argue, is not as safe because it is a way more capable vehicle. In the same way that a 737 is way more capable than a Cessna 172. That doesn't mean that the 172 is a bad idea. Doesn't mean that the 737 is a bad idea. They're just different things. John Honeycutt is shuddering at that question. Yeah, he definitely is. Mm-hmm. Yeah, Wes, the space shuttle, Dragon capsules can't build the ISS. The shuttle could. Dragon capsules cannot do that. Starliner cannot do that. Orion cannot do that. And that's the reason why I explained it that way, Wes. People will disagree with me on it, but the reason why I explain it that way is because generally, when you're talking about space flight, if you want to do more things in space, like if you want to increase the difficulty level, so to speak, it's generally more dangerous. Like going to the moon is way more dangerous than going to low Earth orbit. Like that's a factor of difficulty that's like up here. Like think like if you're playing Halo, if anybody out there plays Halo, that like going to low Earth orbit is playing on heroic. Going to the moon is playing on legendary. Like there's a distinct difference there. All right, it's definitely a big jump in difficulty. Saturn V was way more dangerous than the space shuttle. There you go. Because it does more. That's what I mean. How about if you eliminate all instances of flying spacecraft outside their design and tested limits? I mean, Aguilex, if we want to prove the point that we always make, that I don't think the shuttle was a bad design. I really don't. Really, surely we could fit some ISS modules here or there into Dragon. I mean, you could. Not very big ones. I still think that the shuttle's a great design. I think it's a great design if you're trying to fly it every week, like once a week, which is what they were trying to do. They're trying to hit about 50 launches a year. That's pretty good. That's doable, but it turns out that you have this very complicated vehicle and it's only designed to work in certain conditions, and you try to fly it in uncertain conditions and something goes wrong. Like if that happens to somebody flying an airplane, like if you don't de-ice the plane and take off in the wintertime, that's your own fault. That's not the plane's problem. You need to de-ice the plane. If you don't de-ice the plane, it's not going to work because it's not designed to fly in the cold without de-ice, right? The shuttle wasn't designed to fly in cold weather because it's launching from Florida. Weird, right? So they launched it in the cold and something went wrong. Oh, that's weird. Strange. And, NASA had the gall or politicians in NASA had the gall after that to blame the system. Okay, blame the system. If that was an airplane, you'd blame the pilot for taking off in adverse conditions that the plane isn't rated for. You don't try to take a Cessna off with 30-knot crosswinds. That's just going to end poorly for you. It's not the plane's fault. What's up, Varner? What about launching modules that has propulsion and docking ports to self-assemble? Some manual assembly would, of course, be needed later on. Well, that's called a modular space station design, Varner. Yeah, that is much more favorable to the architectures that we have now. So like Falcon 9, New Glenn, stuff like that. Yeah, it's much more favorable in that regard to do something like that rather than have a bespoke like a station that needs to be assembled with an on-orbit construction vehicle. It makes more sense to do something like Skylab or Mir at this point. And that's what I think NASA should be pursuing. They should be trying to make Skylab 2 right now. And they were for a little while with the new NASA core module thing that Jared Isaacman wanted to roll out, but they don't want to do that anymore. Who knows? If you put too many cycles on the aircraft without doing scheduled maintenance, the people ream the airline for greed rather than say the airplane is dangerous. Yeah, Aqualix, yeah, it's never... The shuttle was designed to be a space plane, yet we judged it like a spacecraft. And then we didn't blame... We blamed the equipment when it was clearly operator error on on whoever was running NASA and gave the go to launch STS-51L, and frankly STS-107 as well. Yeah, that's... Oh yeah, blame the equipment. Sure. Blame the equipment. But anyway, so hey Juan, thanks for the super chat. That's 2,500 DOP. I'm not familiar with DOP as a currency. Fill me in, dude. What anyway? What are you saying here? Any idea why normies are so oblivious to current generation spacecrafts? I was showing some coworkers the Blue Origin pad explosion, and one guy's comment was, "Oh, Dominican pesos. Gracias, amigo. ¿Qué pasa?" All right, so I was showing some coworkers the Blue Origin pad explosion, and one guy's comment was, "Is that where they put the space shuttle?" Normies don't even know the shuttle retired years ago. Okay, so first of all, thank you for the 2,500 pesos. I appreciate you, man. So Juan, this feeds into kind of a theory that I have that NASA needs to be doing headline missions. The reason why everybody knew the space shuttle is because NASA was launching it a lot. And you know, it was building the ISS. It was a very overt thing. People saw it. It launched a lot. SLS doesn't launch a lot, so we don't really kind of
Discovery, go at throttle.
put two and two together. I mean, I had some people tell me that, I was talking to one of my neighbors. Hey, Bob, 10 subs, thank you. And then Marco had a 24 month
this is space. I'm in space.
in there too. Grazie, amico. And Bob, thanks, old boy. Appreciate it. So, like, I had a neighbor ask me, like, "Oh man, they sent the shuttle to the moon the other day. That's awesome." And I didn't say anything because I don't believe in being that guy with people that don't know about the space program. So I was like, "Yeah, man, it was sick. That whole mission was sick." And he's like, "They came in at 25 times the speed of light, right?" I'm like, "Nope, can't let that one slide. The speed of sound, but that's still really fast." Like, so yeah, no, it happens, dude. But yeah, the shuttle, like, the reason why one is NASA doing in-house missions and not contracting stuff out to commercial, it is a cultural phenomenon. It is. And I haven't seen commercial missions like the Commercial Crew Program really capture that same kind of cultural impact as NASA doing their own thing. So the Apollo missions, obviously, or the shuttle missions. The reason why everybody calls it the shuttle is because that's the only thing that everybody lived with for, 40 years? From 1972 when the program started, 1981 the first flight, to 2011 the last flight. It's 40 years, dude. 40 years of calling any NASA spacecraft the shuttle. That's going to take some time to fix. I would argue that if NASA is doing their own things, like the Artemis program, I would argue that is probably launching more, and having NASA doing their own in-house program is probably a better way to gain more recognition and have people not call it the shuttle anymore. Hey, Vent, thanks for the Prime sub. I appreciate it, man. Yeah, exactly. And like, Juan, in English, dude, like, there are, in Spanish too, for what it's worth. Like, I know a little bit of Spanish. That does happen. People just call stuff. Like, there's one name and the name sticks. So, like, I'll speak to cars because I know American cars. Like limited slip differentials, LSDs for short. Every American company in the 50s and the 60s had their own name for what they called a limited slip differential. Ford called it a Sure Grip, and Dodge called it a True Track, right? Chevy called it Positraction, and that's the name that stuck. Americans still call limited slip differentials Positraction, even if it's not on a Chevy. That's just the name that stuck. And I don't know, I guess the shuttle name stuck. Yeah, like everyone calling a copy machine a Xerox machine. Xerox is not the name of the machine. It's a photocopier. Xerox is the company that made a photocopier, and that's just the name that stuck. Or in the UK. In the UK, everybody calls a vacuum cleaner a Hoover. Hoover is a brand of vacuum cleaner that everybody bought, so everybody just ended up calling them Hoovers. So now even if you have a Dyson, you still call it a Hoover. Cornetto, Kleenex, Thermos, pick one. Yep. Yeah, thank you for the super chat though. Yeah, that I blame Marissa Tomei for Positraction. My coworker's American. I think he lives in Texas. That's why it was so painful for you. Oh, jeez. Oh, God. I can't even imagine. You you're from the Dominican Republic, right? You're telling him about that, and he does. Yeah, I could see how that would be annoying. You know, yeah. It's like, oh, you're American. You should know about this. Shouldn't you be interested in all this cool space stuff you're doing? Yeah. The thing is, well, it's a big country, man. Not everybody's gonna be into it. That's part of the reason why I do what I do. I'm trying to change that, man. Oh boy. Did you know the same company that owns Milwaukee owns Hoover? No, but hey, Raven Guard, 74-month resub. Do you think we could do Star Raker or Venture Star or NESP anytime we choose to? Yeah. Hey, Quasi Stellar, what's up? I mean, Juan, that's kind of what I do. I fight that battle every day. Try to teach people about spaceflight and try to show people how cool it is, man. It's cool stuff, dude. It's us at our best. And, you know, I'm parroting Elon Musk a little bit here, and I know people aren't going to like that, but this was something before he started saying it. But spaceflight is cool. It makes you happy because you look forward. It's something to look forward to. It's something that shows, because it shows us at our best. Like, astronauts are all, you know, like physically fit, and they're all super smart. It shows the best of us. It gives people inspiration for what could be, for, you know, reaching your maximum potential. You know what I mean? It's very inspiring, and it's something that I think is part of American culture at this point. Like, you know, this is something that gets thrown around on social media a lot. We're an aerospace republic. We invented the airplane. Now, some Brazilians aren't gonna like me saying that. I know what 14 bis in Santos Dumont is. I know what that is. All right, shh, quiet. Like, the airplane is us. That's what we did. So, like, I'd say the airplane is a part of our culture just as much as trains are a part of British culture because they invented trains. Jeez, Mitch. But, yeah, I don't know. I mean, I think more people should know about it. That's the other reason, guys, why I think NASA should be doing their own stuff on top of commercial, because there is a cultural impact here that you clearly do not get with commercial missions that we've seen over the years. That, like, look at Artemis 2 compared to Demo 2. The Demo 2 flight was the U.S.'s return to launching Americans from American soil after the retirement of the space shuttle in May of 2020. That was a big deal, and that made some ripples, but it didn't make the tidal wave of attention like Artemis 2 did. Artemis 2 was a big deal. Everyone knows about that mission. You know what I mean? See the difference? If you're a long-term spaceflight fan, there's a difference. That's why I've always argued for NASA to do their own thing, because it's part of it's part of American culture, and it's something in a sea of doo-doo that we can look forward to that, you know, we're doing. as a whole country. It's a unifying thing. Actually, I would argue that it's a unifying thing on a human level, not just, state level. But yeah, that's a good question, man. I was so sad when my girlfriend asked me if I saw the moon landing. Well, Nicholas, there's the other thing. Like, look, all right, one other thing, and I'm going to say this to the people that are really into spaceflight. Don't gatekeep. Don't be a douchebag. All right? Don't do that. Spaceflight is an abstract concept to most. I'm not expecting every single person that I talk to know what delta V is. All right? And I would argue that as a spaceflight fan, it's our mantle of, call it a mantle of responsibility. What we need to do, don't be a prick to people about it. Like, if somebody says, oh, did you see the shuttle go up? Hell yeah, I did, man. It was awesome. Because explaining to them the difference between a space shuttle and Orion capsule, they don't care. They don't know what the hell that means. You know what I mean? Don't gatekeep. I never do that. I never do that to anybody in chat, and I don't do it to people in real life either. Like, if you want to call it a shuttle, I don't care. What benefit? What is the benefit there of, getting the word out about spaceflight, correcting people about minutia like that? That doesn't get us more fans. That doesn't get more people being interested about spaceflight because you were a jerk to this person when it came to explaining something. Don't do that crap. If people want to call it a shuttle, call it a shuttle. I don't care. Who cares? That person isn't involved with rocket science, but if you call it a shuttle and you have a great conversation with the person, guess what? They're like, oh man, that space stuff is so cool. That's so awesome. Don't be a dick. Don't do that. It's our responsibility to help get the word out on spaceflight. That's why I'm never a jerk to somebody that has a stupid question. Because it's not a stupid question if you're coming from an area of genuine honesty. Right? Spaceflight is an abstract concept. It's this thing that we just write off as like, oh, it's not rocket science, right? It's not easy to understand. If it was easy to understand, more people would be doing it. Laski, when you get drunk, I always show people Falcon 9 landings on YouTube. Hell yeah, man. Drink to that, man. I don't have a beer with me, but sorry for gatekeeping. Damn it, Kens. Yeah, well, Alex, you're kind of a dick, so. But I'm just screwing with you. But anyway, yeah. Yeah. So, if someone comes up to you and they're like, dude, you like space? Did you see the shuttle that launched the other day? You know what they're saying. Don't be that guy, because they don't know the difference. Yeah, I saw it. It was awesome. Did you see it fly up into space? It's so cool. You want to learn? I could tell you all about that stuff if you want. If you have more questions, I know a lot about it. That's what I usually do. And then, more or less, it's either the third or fourth question. Did we go to the moon? That gets asked the most by normies. Yeah, of course we went to the moon. We just did the other day. Well, why didn't they land on it? Landers aren't ready. Oh. All right. Oh, that makes sense. Yeah, Max, that's what I do. That's why I make it a thing to know. That's why I make it a thing to, get to know who I'm talking to on the other side of the computer. I try to make friends with people because I can't explain something to you if you're talking behind that. I can't tell if somebody's talking about that's talking behind the computer is 6 or not 6, if they're 16 or if they're 36. I don't know. So I talk with you guys. I ask you questions. Hey, how you doing? Hey, what's up with this? Hey, what's going on? So I can understand at least at a superfluous level who I'm talking to. It makes it way easier to explain stuff when the person you're trying to explain stuff to can identify with the source material. That's why I often use cars as an analogy. Because there's way more people out there that understand cars than they do spacecraft. How old am I? I have no idea, Bio. I don't remember. I know you're younger than me, but that's about it. I think you're younger than me, but not by much. Why aren't the landers ready? Yeah, Hellfish, I also... Look. When I'm out in reality, I try not to what I call EJ people. You know, I always am very courteous and ask, how much time do you have? What do you want to know? How deep do you want this to get? We could start talking math if you want, but I'm always very careful about that. You know, how much time do you got? You know, they say, oh, why aren't the landers ready? How much time do you got? You know, depending on that reaction, like give a quick or a long answer, right? The quick answer is landers are complicated. They take time to make. The one during the Apollo program was late too. They take time. That's it. There you go. That's not wrong. That's the right answer. If you go digging a little bit more, you know, if that conversation goes deeper than that, dude, then I start saying like, well, NASA's priorities have not always been the best over the last 20 years. And I generally don't like talking to normies about that kind of stuff, dude, just because it's kind of depressing. And to be honest, I've been trying to avoid talking to you guys about it too, because it's kind of depressing. I have enough sad things in my life, you know, over the last month or so. Like, I don't need to talk about that. That's when I usually change the subject or something. But I never, oh, jeez. I never, what's the way to say it? I never will go EJ on people and talk to the level of detail that I do here unless it was specifically requested. I make sure to not talk people's ear off, because if I do, I won't shut the hell up. Right? An EJ rant about spaceflight in real life must be incredibly hilarious. It's usually one paragraph of me saying NASA has their head up their tail, and they've had their head up their tail until very recently. You know, people ask me, why haven't we been back to the moon in 50 years? Politicians run the space program. They've been running the space program since they realized they could make money off of it. Boom. Done. That's not bullcrap. That's the truth. Sorry. Actually, I was dude, I was at a party a little while back with a bunch of neighbors friends, like on the weekend, right? And I got asked that question by somebody that was skeptical about going to the moon, but the guy is also a big libertarian, right? He's like, why we went to the moon? That's bullcrap. I don't believe it. I'm like, dude, politicians have been running the space program for 50 years. And the guy was like, oh, yeah, I don't like them. Yeah, that makes sense. I'm like, all right, that's one way to get people to believe it, I guess. I'm like, all right, hey, whatever, it worked. You know? He's like, oh, yeah, that makes sense. Yeah, they're idiots. They can never get anything done. They suck. I'm like, oh crap, what did I just do? It's like, I need another beer. Dude, I swear to God, this is a true conversation. This absolutely happened. I'm just like, all right, man. Dude, that I'm not kidding. That absolutely happened. That was a real conversation. Yeah, he was like, oh, yeah, that makes perfect sense. Frick that guy. Okay. All right. Yeah, Nate, exactly, right? I mean, dude, when you explain it like that, it's like, oh, yeah, all right, that makes sense. Trimmer used bureaucracy. It's super effective. It worked. Now that guy likes spaceflight. He's like, oh, yeah, dude, every time I see him, that whole, like, shindig was probably 2 or 3 months ago. Now every time I see that dude, he's like, dude, what's going on with space? That's so cool. I love what we're doing. I'm like, yes, it is nice, isn't it? You know? Yeah, Red, that was, dude, no, that was absolutely a real conversation. And that's what I mean about knowing the person that you're explaining it to. You explain it in a way they understand. It's just like, oh, yeah, no, space is awesome. Oh yeah, we went to the moon. That absolutely happened. I believe that. Boom, done, easy peasy. And it's not. I'm not lying either. That's the truth. Yeah. See, I'm not a jerk to people. That's how you get people to like space. Oh, engineers should be in charge of that. It's an engineering thing. Bingo. Bingo. Like, I guess that's why I can, you guys help me punch my meal ticket because I can put it that way and explain things. Like, but anyway. All right. So, the next bit of news I want to talk about here is the SpaceX IPO. SpaceX released a new website called SpaceXIPO.com. Now, once again, this isn't financial advice. This is an endorsement. I'm just kind of curious what's going on in here. Oh boy, a disclaimer. Company has filed the registration statement Form S1. Presentation and its contents are confidential and proprietary to the company. Okay, information in this presentation is provided in summary form and does not purport to be complete. Ooh, purport. Word. Only time I'll read the terms of service. Presentation contains forward-looking statements. Yep. Presentation or such other date as specified. Presentation or such other date as specified herein. Forward-looking statements in this presentation only speak as to the date of this presentation. The company expressly disclaims to the fullest extent permitted by the law any obligation or undertaking to disseminate any updates or revisions to any forward-looking statements contained herein to reflect any change in expectations with regard thereto or any change in events, conditions, or circumstances on which any such statements are based upon by law. What that says, so I'm semi-fluent in legalese, don't ask why. What that means is this is what we're planning to do. We might do it. We might not do it. I don't know. It's cool. Just watch. No representation or warranty, express or implied, is made as to the fairness, accuracy, or completeness of this presentation and the information contained herein, and no reliance should be placed on it. Basically saying that basically says this is what we're going to do, but it might not be exactly what we're going to do. Like, don't bet on what's in this video being the reason to invest in the company, but we're going to give you a taste. All right, let's see what we got. Is this just a slideshow presentation of the... It is. Okay, it's a slideshow presentation. We'll just use the slides instead. All right, offering summary. Space Exploration Technologies, offering size 555.6 million shares, 100% primary. Over allotment, 15%, 100% primary. I'm not exactly sure what that means. But this is what we want to do right now, no promises. Full screen. All right. Where the hell's that full screen button? Let's try that. Does this work? Good enough. Yeah, Frowlin, I mean, if we're splitting hairs, but yes. In the voice of Duke Nukem, that's a lot of words. Too bad I'm not reading them. I've got stocks of steel. So, offering price, the IPO is at $135 a share. That is ridiculously high for any rocket company. I think the one that's closest or on par with that is probably Rocket Lab at this point. Expected printing date, June 11th. Use of proceeds. To fund the company's growth strategy, including the expansion of AI compute infrastructure and enhancements to launch infrastructure and launch vehicles, increases in scale and capacity of satellite constellations and any remaining amounts for general corporate purposes. So use of proceeds, they need to build out the satellite manufacturing for AI data centers, and they need to build out more launch pads. And it's building more Starship and Starship launch pads, which, okay. increases in the scale and capacity of satellite constellations and then, yeah, okay. 366-day lockup. I don't, for Elon, staggered lockup release for a portion of the shares held by select investors, officers, and directors starting at quarter four 26 earnings through quarter four 27. Staggered early lockup release for other shares starting after Q2 2026 earnings through 180 days after the IPO. Yeah, lockup is how, yeah, you have to hold the stock. I got it. The video is the CFO speaking and it's not a slideshow. Oh. Okay. Let's see what we got.
Hi, I'm Brett Johnson, Chief Financial Officer of SpaceX for the last 15 years. Only one the company's ever had, actually. And it's a pleasure to talk with you about SpaceX. But what it immediately does is it enables our connectivity business to grow meaningfully, and now AI as well, where it's not just growth of our own platform on the infrastructure side, it also allows us to start hosting others and building out that piece of our AI business model.
Increase launch payload capacity, establish lunar economy, including cargo transport, manufacturing, and energy production on the moon. Grow Starlink, enterprise and government customers, expand our Starlink mobile offering, increase the capacity of our constellations, grow consumer AI platform monetization, grow X monetization. You skipped ahead 12 minutes. Sorry.
It's a pleasure to talk with you about SpaceX. Elon started SpaceX with the goal to change mankind and make us a multi-planetary species. And what's been very exciting is we've been able to expand that mission with our Starlink constellation, as well as with our AI solutions. At our core, we're really builders. We're the only company building the integrated hardware and software infrastructure to really power multiple businesses. But we started back in 2002 at our roots as a space business. We achieve what others think is really the impossible, and we make that possible. If you look at some of the milestones that we have accomplished already in the space business, we're the first private company to develop and launch a liquid fuel rocket and reach orbit back in 2008 with the Falcon 1. We're then the first private company to successfully dock a spacecraft for the International Space Station in 2012. The first to successfully propulsively land a rocket from space, specifically the first stage booster back in 2015, and refly an orbital class rocket booster in 2017. The first private company to launch astronauts to orbit and fly to the International Space Station in 2020. We are the first to have really a fleet of rockets that end with reusability and drive from Falcon reusability today of the first stage to full reusability with Starship. 23 metric tons of capability with Falcon 9, going to 64 metric tons of capability with Falcon Heavy, to now about to be 100 metric tons with the version 3 of Starship. And really, from a rocket reuse perspective, that has been the unlock mechanism. It's really driven down the cost of launch and given us the ability to drive up launch cadence. Specifically, having a hangar full of rockets to show our launch customers, or having the ability to ramp to, just last year alone, 165 launches of our Falcon 9, and now moving into fully reusable with Starship.
Pretty crazy, huh?
Starship really has an unparalleled capability from a cost efficiency perspective. If you look at where this industry has been historically and where we were able to get to with just first stage reuse on the Falcon class, where we were able to drive out 85% of the historic cost. Now,
can I just see this for a second? Step function improvement in reusability. Launch cost per kilogram to low Earth orbit. Average launch cost from 1970 to 2000 was about 18,000. Falcon 9 is down to 2,700. Heavy is 1,400. Target reduction is 99%. They want to get Starship down to as low as below 1,000. Yeah, I would like to add that this number is high because the shuttle didn't launch a lot, even though it was designed to launch a lot. Remember, if you were here for the earlier part of Space News, speaking to the programmatic failures of the shuttle program. It ain't the shuttle's fault. became that became that way. It was the people in control of the program.
Now we're looking at a vehicle that's intended to go drive a 10x improvement even from where we were already industry leading with Falcon. Along with the unlock from a cost perspective, Starship also gives us an unlock from a throughput perspective. So you see with Falcon 9 in the expendable category, let alone Falcon Heavy at 64 metric tons, going to 100 metric tons with version 3, and then already starting to work on version 4 in the design that should double that again to 200 metric tons to orbit. We talk about the mission and certainly how we accomplish the mission. One of the reasons that we're able to do this is we run what Elon calls the algorithm. And the algorithm starts with, first and foremost, making the requirements less dumb. Questioning the requirements is a key piece of our culture. We then move into deleting parts and process steps, and you see that as an example in the picture here, where you have the first version of the Raptor engine on the left going all the way to Raptor 3. And then once you delete the parts in the process step, you move into optimization, acceleration, and automation. And then pivoting to the connectivity business, again, the connectivity business is really enabled by our core launch capabilities. We have now launched and operate a high-speed, low-latency global broadband constellation, otherwise known as Starlink.
That's ridiculous.
And really, we feel Starlink is an unrivaled satellite constellation. The V2 satellites that we fly today on Falcon deliver 96 gigabits per second per satellite, and we fly roughly 27 satellites
look at the
per
hold
launch.
on. I've never seen that before. So the Starlink factory is in Washington State, where they make them. I've never seen them load them up on a trailer.
And we fly roughly.
Can you imagine? Just somewhere driving around, you're going to see an indistinct, slide cover trailer. It's just full of Starlink satellites. You've probably, honestly, if you're a trucker, you're out on the road, you've probably seen them. Didn't even know it. And yeah, SpaceX moves the engines around in a trailer very similar to this. So how these trailers work is they have a slide cover. So the cover slides home and covers up the entire trailer, and it just looks like a box trailer.
27
Yeah, we've all probably seen them.
satellites per launch. But the V3 satellites we're about to fly in the back half of this year are a huge step function in capability. In fact, per launch on a Falcon today with the V2 satellites to the version 3 satellites, it's a 20x improvement related to the capacity per launch with version 3. And in fact, that translates into, with 60 satellites flying per launch on Starship and each of them delivering roughly a terabit per second, that we will be able to fly 61 terabits per second of downlink capability per launch of Starship coming up here. What that quickly translates into is after 20 launches of Starship, we will be launching 1.2 petabytes of capacity per year. When you start talking about in petabytes, you start actually looking at the Starlink network as a percentage of global internet.
Halo 2 multiplayer screen? Anyone? Anyone? Halo 2 multiplayer lobby screen? Who knows? Who knows what I'm talking about? Yeah? You know what I mean. Sorry, it just reminded me of that. Those are good times. Yep.
Traffic. It's also important to note that because of the fact that we're delivering from space, we're able to deliver in many areas and in many cases where terrestrial just can't deliver.
Where boats do deliver. This is fake. That tree's underwater.
Whether it's low density populated areas,
Discovery,
whether it's very remote areas, whether it's in very challenging topography where you just couldn't handle it from a terrestrial perspective, or on the mobility side, in the air, on the ocean, and we've been able to demonstrate over and over again being
really, Vasia? Hold on.
Satellite internet network, roughly over 9,600 satellites. You look at all the others combined, and they're a fraction of what our constellation is.
Yeah.
We're actually representing 75% of all active
saying.
maneuverable satellites in orbit at this point. And our user base is significantly expanding. So we ended 2024 with roughly 4.4 million users. End of last year, we had roughly doubled year over year in the number of users to to roughly 8.9 million. And now, as of the end of Q1, approximately 10.3 million users on our network, over 100% year-over-year growth. Over 164 countries/territories that represents over 3 billion people being covered by our network. And as more and more companies and industries look to resiliency and reliability as critical capabilities, you're starting to see Starlink being brought in as...
Actually, you say then the sun farts and the whole game is over. Where's the redundancy? The Starlink satellites are inside of the magnetic field. They're in low Earth orbit. It's a proliferated network. It's called a PLEO constellation. Proliferated low Earth orbit constellation. So because it's PLEO, you're inside of the magnetic field. So you don't necessarily need to rad harden the satellites as much as you might think. Second part about that is, honestly, the redundancy. The redundancy is reusability in Starship. If Starship, if say you do have a solar flare, you have high solar activity, right? And it hits some Starlink satellites and fries them. Because they're in low Earth orbit, the atmosphere will pull them back down and they'll deorbit, and then you just launch another Starship with more Starlinks in that shell and you just replace it. Think of it like a drone swarm, right? Like, you know, you take out one, another one takes its place. That's the whole idea. It's actually pretty smart, dude.
Either the primary or at least the backup solution in a lot of the fixed site as well. Aviation specifically, I have to call out because there's a tremendous amount of traction. You see an announcement almost every week now related to another airline talking about Starlink adoption. And then also on the government side of the business, delivering Starshield capabilities, a whole separate constellation for the US government. Again, resiliency being critical here in delivering core capabilities. And then the other piece of our very diversified connectivity offering is direct to the handset. So direct to device, we started out with our Gen 1 solution, which was really a proof of concept. We flew 650 satellites, turned on a service with 30 different mobile network operators around the world, the largest being T-Mobile in the United States, have coverage now for 1.9 billion people, and have proved that there's certainly a demand and excitement about having this capability. We now are in work to fly our Gen 2. This is full 5G quality to your phone. I think this will be the transformational unlock of connecting the other 3 billion people on the planet that had really been left out from the digital divide. And then lastly, our AI business. It is really exciting to talk about where we're at from an AI perspective, because this is again following that same repeatable business model that I talked about, leveraging that unrivaled launch capability. We looked at following down the same path that we had done with the other businesses and really owning the full value chain all the way to the end customer. What made the most sense is for us to have our own frontier model and be able to capture all of that value. And so that's exactly what we did. We now have the world's largest coherent supercomputer with...
That cable management, though, it's pretty nice. Pretty nice to look at. That's pretty cool. Did you see that there was a study for Starlink reentries that might be pretty bad for the upper atmosphere? That one hurts. I mean, Kerbal, yeah. I honestly think it's a drop in the bucket compared to other things, but yeah, I'm not going to say that it doesn't. Probably does.
Colossus 2 data center that we stood up with
Dude.
best-in-class compute.
Look at the damn cooling systems. Holy crap.
GB300 specifically from NVIDIA. We have the first gigawatt scale training cluster, the first gigawatt scale megapack battery installation there as well, and first to deploy the GB200s and 300s at significant scale. And so, you know, having a gigawatt of nameplate compute draw is really compelling for us. But certainly I want to talk about the orbital AI compute that's coming in the next couple of years, because this seems to be the future of AI infrastructure. And this is the clean energy solution. This is the solution that really addresses some of the concerns related to AI data centers popping up.
I still can't believe we have this footage.
The distribution capability that others may think is a constraint related to this, we've already demonstrated with our Starlink network today. And having, in essence, no operating cost because you're leveraging the power of the sun and cooling as radiative cooling off the satellite makes this readily available and incredibly cost efficient. And so we are ramping up this capability right now and in essence leveraging a ton of capability that we already have in place, whether it's the ion propulsion thrusters, whether it's the inter-satellite laser links between the satellites or the flight computer or reaction wheels. Again, a lot of technology that otherwise would be blockers to doing this in the near term, we have in place. It's why we feel like we are the only company that can do this in any meaningful time frame. And what matters related to AI infrastructure is really creating that business model where if you start at the very top and leverage that connectivity capability that we have to drive that infrastructure advantage for us, we then get to go right into the cycle of leveraging that, driving improved quality of intelligence and lowering the cost at the same time of our token cost, monetizing that and driving that reinvestment back into that cycle of infrastructure. We certainly demonstrated our capability to go monetize this infrastructure with key partners in the industry. For example, we signed a deal with Anthropic just recently to give them access and host their model on our data center, while at the same time allowing us to make investments in our own model, with an example of that being the deal that we announced with Cursor related to improving our own coding capability on our compute resources. So continuing down the path of monetization and leveraging our, what we believe is best in class in the industry, deployment of cutting edge compute, and at the same time, continuing to invest in our own models to even further that monetization in the future. I would be remiss if I didn't talk about the fact that we believe one of our differentiators related to our models is certainly the fact that we are designing them as advanced truth-seeking AI from the very beginning. It's certainly one of the reasons that Elon got into the AI business to begin with, is to have that really truth-seeking model. We certainly are also going to leverage the X platform that we have in place now that really brings us real-time information. Real-time data is, I think, critical at all times, and I don't know that there's a better place to get real-time data than on X. So our growth strategy starts with space, increasing our launch payloads, getting to full reusability from Starship perspective, and certainly over time opens up whole new markets in the space industry. But what it immediately does is it enables our connectivity business to grow meaningfully, and now AI as well, where it's not just growth of our own platform on the infrastructure side, it also allows us to start hosting others and building out that piece of our AI business model. So there's almost $6 trillion of available market that we're going after, really in three pieces. We are moving faster and cheaper than others in the industry, even related to deploying terrestrial compute. And we think over time, the enterprise AI market is massive. So an incredibly
See that right there? 22.7 trillion for enterprise applications. Guys, that basically means that we don't know exactly what we're going to make money off of AI with, but we know we're going to make money off stuff. It can do things. What kind of things? Well, we don't know yet, but it'll be able to do things. So that is planning for future markets here. And if you notice, that is a very large swath of this. And now here's the flip side of that. Some of you are going to look at that and say, yeah, okay, pal. There's no doubt that AI will have its place, but I think 22.7 trillion most likely represents ideal scenario of where SpaceX thinks they could take AI to, like, replacing everybody's job or something like that. Like that's I think that represents a theoretical maximum. But yeah, I don't know.
Large total addressable market that we're going after.
Putting it politely, it's ambitious. Yeah, that I actually want to rewind it. I just want to hear what he has to say about that.
We think over time, the enterprise AI market is massive. So an incredibly large total addressable market that we're going after, over $28 trillion. Not only are we positioned for those markets today, but I think it's exciting to talk about where some of the future growth beyond that really is even happening. And certainly when you start talking about space, we start to talk about point-to-point transportation terrestrially, manufacturing or productivity, potentially asteroid mining in the future. And I think very exciting also is the lunar economy. The fact that we're on track in the next couple of years to put boots back on the moon, being able to build out sustainable capabilities on the moon, I think in the years to come will be a tremendous unlock for humanity. We feel like we've had a stellar track record already related to capital allocation and value creation. If you look at even in the life of the company from a space and connectivity business, the fact that we really only raised $9 billion and have created the business that we now have today with last year alone. Generating $7.8 billion in positive adjusted EBITDA, while also investing for the future with another $3.6 billion of R&D just last year alone. I think clearly we have demonstrated both on the capital allocation side and the value creation that this is what we're all about. And what that means from a financial perspective on top line, revenue has continued to grow meaningfully year after year after year. In fact, in 25 alone, over 30% growth year over year, just as we were starting to ramp, in essence, in the connectivity business. In generating that roughly $19 billion in revenue, also generated almost $7 billion in positive adjusted EBITDA just last year alone. And then in the connectivity business portion, you can see the significant step up where we grew roughly 50% in 2025 year over year. And then as far as building the infrastructure.
Can I look at that one more time? Interesting.
Year over year. And then as far as building the infrastructure of the future, that typically takes capital. And so we are not alone in investing meaningfully in CapEx, especially in the AI side.
$3 billion annual space R&D on that side. Your theories about Starship are right. Aqualix, that you can't. There's no cheaper way to get to space. The only cheaper ways you're going to get to space is if we have a better propulsion system, like a warp drive or something like a Star Wars rocket engine or the Epstein drive or something like from The Expanse. It's the only way you're going to lower the cost. The only way to beat it with conventional chemical propulsion is scale. And that scale is always going to cost you billions of dollars because we can't spend our way out of breaking the laws of physics. Unless Ephraim Cochrane comes around and makes us a warp drive, we're kind of poop creek without a paddle there.
Side of the business now, and that's been the lion's share of the
CapEx
deployment for the last 2 years now that we have consolidated in our AI business into the fold here, where just last year alone, roughly $21 billion of CapEx, but a large percentage of that was for AI. And you're already seeing us monetizing a decent amount of that with the hosting deal that we just announced on the Anthropic side. And then on the financials for Q1, we delivered roughly $5 billion of top line just in the first quarter. The connectivity segment alone was a highlight with roughly $3 billion of that revenue just in Q1. But if you look at where we think we will be in the longer term, our future model, we think that our revenue growth will be even significantly higher than that year over year. We think our gross margins are more like 70%, and that our GAAP net income margin is more like 45%. And so we're very excited about where we're ramping into related to the profitability of business and yet the significant growth that we believe we're
I saw it, Bill.
And so lastly, why?
They have a deal with Anthropic to the tune of $1.25 billion a month to use their compute infrastructure, and then now $920 million a month with Google. SpaceX is raking in $2 billion, over $2 billion a month from leasing out time on their compute clusters, which is that's enough to fund a Starship program. That's enough to fund, and that's the other thing that I've always said. Spaceflight is not as expensive as everybody thinks it is. It's definitely not expensive at a government level, right? It's not going to cost like $60 billion to build out a moon city. Really isn't. That's a $10 to $20 billion program all day to build a moon base. Yeah, not nearly that expensive. $2 billion a month, roughly, what is that, $24 billion a year? I mean, not all of that would go towards Starship, right? But even if a quarter of that went towards Starship, which would be $6 billion a year, that is more than enough to make Starship work. That's more than enough to get full reuse working. That is more than enough money in research and development and iterative flight testing to get this thing working. What I'm trying to tell you is that don't bet against Starship. It will work. There's enough money and there's enough tools and there's enough talent to get this done. When it's going to get done is where I've always been like, nobody knows. Nobody's ever built a fully reusable system like this.
Do we think we're going to win? I think it starts first and foremost with our global leadership position in orbital launch services. We have an unrivaled satellite and connectivity platform that really leverages vertical integration from design, manufacturing, deployment, and operations. And now really truth-seeking AI models enhanced by real-time data from
That's
our
right,
Nexus
Discovery,
platform.
go at throttle.
That extreme vertical integration really enables high velocity and superior cost efficiency at scale. And really, the business models are incredibly difficult to replicate, right? Because of the fact that at the core, you first have to have that global leadership position in orbital launch. And so that unique ability to scale into new trillion-dollar markets across space, connectivity, and AI is certainly a reason that we think we're going to win and continue to be this mission-driven culture that is enabled by our world-class.
Yeah, Kujiman, exactly.
Thank you very much. I appreciate the opportunity.
But in the interim, nervous, impatient investors will drive the price down like Astro or Rocket Lab. Two things. Not financial advice, etc., etc. Honestly, I would wait for Starship to be fully operational before IPOing. That's just me. I don't know why they chose to do it now. I'll be 100% honest with you. That doesn't. I don't understand why you would do that. None of this matters if Starship doesn't work. To be quite frank. Or EJ, Frank's cool too, but yeah, none of this matters if Starship doesn't work. Why would you IPO before Starship is operational is beyond me. I don't really understand why you'd do that. Yeah, Lava Eagle, I'm strictly talking from like just a business model standpoint and knowing what I know about spaceflight architecture. You guys are saying that people are going to tank the stock. I think that Starship will tank the stock well before that, well before the people do. And don't get me wrong, it's not going to go, they're not going to go bankrupt. Did you see those numbers? That's not happening. Starship will tank the stock with, every time a Raptor engine goes out on the way up. The Raptor engine went out, you'll see some finance bro being like, well, if one Raptor engine goes out of flight, that means that's an average of, 32 Raptor engines working, and 1% represents risk in your investment, and here's why. And it's just like, shut the hell up, dude. You have no idea what you're talking about. Building out infrastructure for AI satellites and terafab. Milge, you keep saying that, you build all the factories you want. If you can't launch anything into space in the way that you want to, what are you going to use? Falcon 9 to do this? Just putting it out there. Like, And once again, is Flight 13 going to go well? I want Flight 13 to be 100% successful. That would be fantastic. But I don't think investors understand what iterative prototyping is. I don't think so. Iterative prototyping means that it might blow up, and if it blows up, that's okay, because that's the rule set in the framework that you came up for your mission parameters. If it blows up, it's not a big deal. This is why when SpaceX blows something up, it's whatever. I mean, it's not ideal, but it's not that big of a deal comparatively to, like, if your rule set is we want to launch it and we want it to work 100% successfully, and you say you want it to work 100% successfully, and then it doesn't, then you got a big problem. Or if it blows up on the pad, you got an even bigger problem, right? SpaceX has they lean into that iterative design. Now, iterative design isn't without risks. If you're looking at it from a purely pragmatic financial standpoint, iterative design is such a risky investment that nobody would do it. No finance bro that's looking to make a quick buck would ever do something like that, because iterative design trades, high flight rate. Because you have a high flight rate, you are trading mission success with knowledge and understanding to prove out mission success in the further down the road. So, like Flight 12, super heavy blew up. It blew up because an engine exploded during boost back. Somebody who doesn't understand iterative design would look at it and be like, "Oh, it's such a failure. I'm not investing in this. It's a failure. It doesn't work." I see people make this mistake all the time. You're looking at it like you'd look at it like if it was NASA or something. Everyone knows about Challenger and Columbia and stuff, and knew that was a big deal, and that stopped the space program, et cetera, et cetera. I'd be worried that people that are investing don't really understand what that means. My biggest worry with the IPO is SpaceX will be subject to fiduciary responsibility. Elon still has controlling stake in the company. With this IPO, they've spun off only a portion of shares. You can do that. It's so that shareholders will never gain majority stake in the company. Elon has retaining stake in the company like big time. He owns 70% of the company or something ridiculous. He's well beyond like controlling interest here. So there is a fiduciary responsibility to shareholders, but it's not going to tank the company. Like, you're not letting finance bros denote your rocket architecture, thank God. Yeah, Tesla's the same way. Mm-hmm. They still have to act in the best interest of the shareholders as a whole. Yes, but it's not to the point where you would see SpaceX just like completely pivot into AI and Elon would not have control. Or it's not just him. Elon or anybody else wouldn't have control of what's going on. That's all. It's not. It's not. It's not. They won't Dodge Brothers the company. Don't worry. And I can say that with the utmost confidence because that was bothering me, and then I went and had to go do some learning about how their IPO is working, et cetera, et cetera. And I wanted to talk more about this yesterday, but I got to get ready for Flame Trench. One man, your son works for an investment bank involved with the IPO. The internal message is to not touch this with a barge pole. NASDAQ is forcing companies to invest as they are worried about stock dump. Yeah, the flip side of that, guys, is that finance bros are going to look at that $22.7 billion investment, what was it called? The $22.7 billion in enterprise applications, and no, that also in itself is not a safe investment. Anytime anytime there's risk, yeah. Let's just say that because money is involved, traders are very risk adverse. And that's the other reason why I don't really understand why you would IPO before Starship is fully operational. But then again, maybe in SpaceX mind, fully operational Starship is just good enough to deploy Starlink satellites, you know, and in my mind, fully operational Starship is HLS. Starlink is already printing money, so why not? Please look at page 22 and 23 of the S1 filing. I literally just told you that I did that. Also, don't yell at me. Yeah, we'll see. We'll see, fellas. I have my, this is not financial advice at all. I have my reservations about this. I personally don't think that IPOing is a good idea. I understand AI, computing, etc., etc. You got to race everybody. You know, I understand that. I get it. I know why they're doing it. It's just as a space flight, like, see, that's the thing. As a space flight fan, I don't really care. Like, is that the right way to say it? And I'm not to disparage people that are very pro AI either. It's just not really. That's not the inspiring future that I look forward to with spaceflight. Hey, Renren, what's going on? But you see, the flip side of that is that if AI is your means to that inspiring future end, and in Elon's mind it is, then maybe it'll be all right. Yeah, spoiled maybe. Biggest worry is that the AI stuff will tank space valuation. Yeah, I don't know. We'll see, guys. It's hard to say. Like, we don't know. There's a lot of risk involved here, but there's a lot of reward potentially involved here. Dude, that enterprise application, $22.7 trillion in potential enterprise applications. If half of those enterprise applications go right, that's still $11.35 trillion. That is an insane, quite frankly, insane return on investment if even half of this works. Heck, if even a tenth of it works, it's still bananas. Once again, this is not financial advice. I am not a stock person. I don't know anything about. I know what like a share is and price per share, and like I have a very superfluous understanding of this stuff. So just bear with me here. I can speak to you about spaceflight architecture. But yeah, I mean, I don't know. I'm gonna be honest. If I was running SpaceX, I would just keep it private. You're already making money from Starlink. Just yeah, I don't know. How real are rockets? Oh, they're real. I've seen them launch. I've seen them with my eyes. He wants his bag to get bigger faster. Well, yeah. The reason why he's doing this is because my guess would be in Elon's mind that none of it, Starship being fully reusable doesn't matter if AI destroys everything. Pretty sure that's the impetus here, but who knows? Can we get Stockmo's opinion? Stockmo can't come to the phone right now. Please leave a message after the beep. Yeah, Fluffy, me too. I wanted to talk about this IPO stuff on Flame Trench, but I don't. Yeah. I changed my mind. I don't want to. All I think this will do is just get people pissed off in the chat because I kind of used you guys as my trial and error here. Maybe we'll just stick to talking about ISS leagues. But anyway, I got to get ready for it. I don't know whether you want to invest or not want to invest. Just keep in mind, this isn't investment advice or anything. It's just I wanted to see if there's any new if there was any new space flight information there, and we got to see some cool pictures of the Starlink factory. That's kind of neat, but yeah. That's what I was kind of hoping, that they'd, in their investment thing, that they'd show something we haven't seen and we could talk about that, but that clearly wasn't the case here, so I'm not, I'm gonna go tell Kevin and Sawyer and Max that I don't want to talk about this. Ladies and gentlemen, we got her. Here's a little bit different news before I go to do Flame Trench. Huh. Interesting. No, I'm not giving you context. Figure it out. All right, dudes. So, what I'm about to do is go get ready for Flame Trench. This is we'll be talking about what's going on with space flight this week here in a moment. 47, she's inspired by the bird of prey. I know what it is, Baron. What? All right. I'm gonna go. We'll go talk about spaceflight stuff. So there's plenty more spaceflight stuff to talk about. But on the YouTube side of things, because we stream Flame Trench on YouTube, I am going to shut the YouTube stream off. On Twitch, just give me probably about 15 minutes, and we'll be ready to go for Flame Trench. Yeah, I'll see you guys in about 15. Yeah, and on YouTube, I'll see you guys later. Stand by for loss of signal on YouTube as expected. Stand by for acquisition of signal of Flame Trench on the Twitch side of things in about 15 minutes. I'll get the music going too for you. So I will be back in a little bit with my buddies, and we will talk more about space, and it'll be great. Thank you very much for watching.